Who are you and what do you study?
Yeah, so my name is Maura McLaughlin. I'm an astronomer, and I'm a radio astronomer, so I use big radio telescopes, and I study a type of star called a pulsar. And a pulsar is a neutron star. Neutron stars are a very special type of star. They're born when a massive star explodes at the end of its life, and the core of these massive stars collapse in on themselves. They rotate really rapidly. They're super dense. They're like the size of a city, but the mass of the sun rotating almost 1,000 times a second. So they're super extreme stars, and they emit radio waves every time one of these stars rotates. It's kind of like a lighthouse, like a radio lighthouse in space. You detect a pulse of radio emission. So that is what I study. There's lots of things you can do with these pulsars. They're really interesting objects. And one thing I'm trying to do is use them to detect gravitational waves, which are invisible ripples in space-time, but they affect the arrival times of these pulses. So we time these pulses very accurately to look for little perturbations, little changes in the times due to these invisible gravitational waves.
What secret of the universe do you most want to find out?
Well, there's two secrets. So can I talk about two secrets?
Sure.
Okay. Yeah, so with my research, I would say there's two kind of big secrets that I'm working on finding out. One of them is how galaxies have evolved, since the first galaxies were formed all the way to now. We really don't have a super good picture of how galaxies have started from little clumps of mass to the big, beautiful spiral galaxies that the Milky Way is today. And with our experiment, we're trying to detect gravitational waves from galaxies that were formed a really long time ago from huge black holes at the cores of these galaxies. And when we can make that detection, we're going to be able to basically map the history of galaxy formation and growth over billions of years. So that's one secret that I'm working hard to find out. The other big secret that I'm really interested in is general relativity. Have you heard of general relativity?
No.
Okay, so Einstein, about 100 years ago, he came up with a theory of general relativity, which is a theory of gravity, which tells us that if you have masses, they distort space-time, which sounds like a very abstract and crazy concept, but it's a very mathematical description of gravity that works perfectly. So far, every prediction that Einstein's made based on this theory of general relativity is correct. The existence of these gravitational waves. General relativity is needed to make GPS work. Your phone's GPS wouldn't work without these little corrections due to general relativity. Yeah. And it's interesting to me because gravity is so basic. You know what gravity is, right? You drop things, they fall. That's gravity. It's such a basic physical concept, but yet it's really so complex, and there's so much complicated math that goes into this general relativity theory. But amazingly, all the complicated math is absolutely perfect so far. It describes everything completely accurately. And so I'm doing a lot of tests using these pulsar systems to see if general relativity at some point kind of breaks down. And this could be really important because it might trace back back to that Big Bang era when we really need to kind of see how all those forces gravity and electromagnetism come together and kind of work together. So that's the thing that I'm working on a lot.
I have a question for you.
Yeah.
Why do you think kids should be excited for science?
I think most kids, almost every kid, is excited about science, even if they don't call it science, right? So I think every kid is excited about why are the leaves green, or why do thunderstorms happen, or so I think that nearly every kid is excited about science, whether they admit it or not.
Yeah.
And I think it's just part of the human experience, right? To have that natural curiosity. It's amazing. It's so beautiful. Science is just, there's so much beauty and elegance and amazing things. So even if people don't want to be a scientist, even if, you hate math or something like that, I think science is way bigger than just sitting down with a pencil and a paper. It's really just understanding how the world works. Yeah, I think we're all scientists, even if we might not call ourselves that or realize it.
Thank you for being here, and I hope you do good on your science.
Thank you. Yeah, we're pretty close, I think, to making a hopefully big detection of these gravitational waves. So the next year, hopefully, will be really exciting. Fingers crossed.
Yep.